right, well, welcome everyone. Can you guys hear us? This is my
Yep.
first of the silent disco. So, and then we also
Yeah.
have people over there that we can kind of hear. So hopefully it's okay. But again, thank you all for coming. My name is Anna McAbee, and we're here to talk about detecting and responding to threats and in generative AI workloads. So, with me is Steve.
Hey everyone, my name is Steve DeVera, and I'm part of the AWS Customer Incident Response team. Who here, by show of hands, has actually heard of or worked with or knows about the AWS Customer Incident Response team? And if you haven't, that's great. That might actually be a good thing because it means you may not have had to deal with us when dealing with a customer security event. Anyway, our job is really to assist customers with incident response as they're dealing with security events on the customer side of the shared responsibility model. And my other jobs today to really educate and kind of inform you as to how our processes around investigation and incident response are used with generative AI workloads and application. And my secondary job today is to hopefully entertain you as well with some really bad jokes and some really unnecessary Taylor Swift references.
Yeah, I love Taylor Swift, so he kind of got stuck with the jokes. So. But anyways, today, this is what we're generally going to go over. So we have some foundations. This is a super new subject, and so I think it's important to lay some foundations on generative AI if you're not familiar with it. Then we're going to actually go through the framework of incident response on those workloads and discuss an example incident. So applying those concepts and then providing some key takeaways. So hopefully you guys as customers can actually have things that you can bring back to your organization. So whenever I talk about generative AI and security, I like to differentiate the areas that there are because you will likely hear a bunch of different areas within this week. And so first and foremost, we have security of generative AI. So this is actually the applications that use generative AI. How do we secure those? So you're building maybe a chatbot within your organization. How do you secure those? Next is using generative AI for security. So we have a number of talks on this. I'm speaking to it at a later date as well. And this is actually how do you use it as a security professional to make your life easier. This could be through, just prioritizing alerts, summarizing things along those lines. And then lastly, security from generative AI threats. So if you're familiar with the OWASP Top 10 for LLMs, that would be a starting point for this. And this could be things like deep fakes or how do you generate phishing emails, for example, from generative AI. So it could be a resource for threat actors as well. We are primarily focused on number one here. So we're assuming a generative AI application has been compromised, something has happened to it. And so, sorry, a bit distracting. So we're assuming that a generative AI application, such as a chatbot within your organization, has been compromised. We're investigating it. So our focus is on number one. I do want to recognize the others just to differentiate them. To go forward with some foundations with generative AI security. So you have, first and foremost, applications that leverage large language models. So within AWS, this is your Amazon Q family of services. So you're not necessarily directly interacting with the large language model. So we have, to start, is the first group and the most managed services, and this is your applications that leverage large language models, so the Amazon Q family. So this could be things like Amazon Q Developer, where you're getting suggestions for code. You're not necessarily writing all the prompts yourself. You're typically interacting with some sort of SaaS product in this family, and then that is in turn interacting with the large language model. Next is your tools to build with large language models. We're mostly going to focus on this space today. And so this is Amazon Bedrock, which I'm sure you'll hear more than enough of this week. And this is really meant for developers to use in order to build with LLMs. You're typically interacting with a large language model and you're issuing APIs. So you are directly doing that. You're not maybe abstracted away. And then lastly is the infrastructure for foundation model training. So if you do go down the route of wanting to develop your own foundation model, that is an option. I would say this is probably the most rare. And usually if I'm in a customer scenario, I may try to talk them out of this scenario. It's meant for a very rare situation, but I do want to at least mention it as something is you can develop your own foundation model if you would like. And you would do that through the GPUs, maybe SageMaker, something along those lines. We're primarily focused on the middle one because that is really where our customers are focused and where we see the most people using their applications and the most just opportunity for our customers. So what does this mean for security? So hopefully if you're here and this is a 400 level talk, you're familiar with the shared responsibility model. But what this means is that last scenario, you would be responsible as a customer for the most, right? Just as with the EC2 instance, if you're using that as a file store, you're responsible for the most. So you'd be responsible for things like the operating system, patching. If you have access to it, generally that's what I tell customers, you're responsible for configuring it properly. Same thing is true with generative AI. Next, would be this middle one is bedrock, what we view as like the responsibility model. You're responsible for what you put in, so things like the prompts, as well as just how you configure it, ensuring the right network traffic protection, firewall configuration. And then lastly, this would be like the least responsibility. So something like Amazon Q. What I reference Amazon Q to is something like S3, where you're really abstracted away from things. It's easiest as a customer from a security perspective, I would say. And so it's not as customizable, but there is a lot of advantage when it comes to the customer responsibility. You have more things built in for you. But again, we're going to mainly focus, for the sake of today, the middle one, because that's where we see the most adoption from a customer perspective, and hopefully that's the most relevant. So now that we have these foundations, the core of what we're talking about today. So how do you do incident response on these applications, right? So how do you do it on a chatbot, whether it's built on Bedrock or Q? How do you do that? Well, it still starts with the same thing that we should always reference, and that's the incident response lifecycle. So if you're not familiar, you always start with preparation. So this is still a people, process, and technology problem. And from there, going on to detection and analysis. This is the identification of the incident, and then scoping, is this even an incident altogether? And then next going into containment, eradication, and recovery. So that would be where you're removing a threat, containing, I shouldn't say containing when explaining containing, but minimizing the risk of an incident. And then lastly, post-incident activity. So this is learning from your incidents and making sure that you're iterating on your program. So with each of these, we're going to go back to this at the end to understand like how AI and ML applies to each of these and what takeaways you guys can have. But I did want to at least introduce these foundations to generative AI security, incident response, and now get into the meat of it.
Awesome. All right, so now we're going to take a look in a little bit more depth in about security and incident response on AI ML and the way we use the methodology for incident response on AI ML. Now, one thing we want to determine or take a look at, highlight, is that there are two types of security events involving AI ML. There is the security event where the AI ML application or workload is the source of the security event. And so an example of that would be where if someone uses a chatbot and they're attempting prompt injection and they're attempting to coerce the AI ML model to actually provide data about itself or provide data or resources behind the actual AI ML application. So that's where the AI ML workload is the source of the security event. But we also have security events where the AI ML application or workload is actually the target of the security event. So you'll have basically a threat actor coming into an account, an organization, and what they're trying to do is find AI ML resources. They're going to look up Bedrock. They're going to try and basically steal tokens and things of that nature. Now, it could be either or both, but they're the two types of security events when it comes to AI ML workloads that we're going to use and use specifically the model to investigate and conduct incident response on. Now here there are 5 different components of the AI ML model. The first one is organization. And when we're talking about organization, we sort of define that as the institution or the corporation that has access to an AI ML application. It may or may not have compute resources, and it may or may not also have data. But the main thing is it has access to an AI ML application. The second component that we see is that it would have computing infrastructure. And as an example of computing infrastructure, you have your ECS, EKS, EC2 instances, Lambda functions, but also as part of computing infrastructure, there would be database resources like clusters, Aurora, RDS, right? So that's the second component. Now the third component is the actual AI ML application itself. Now the AI ML application is kind of split into 2. So you've got your models, so your foundation models, your custom models, your guardrails, and then you have the items that train those models and fine-tune those models. So there we're talking about knowledge bases, your agents, your training data and plugins, right? The fourth component of the model is private data. And with private data, we're kind of separating that from training data. Private data would be pretty much your sensitive, your confidential information, your plans for the rocket ship, or sensitive cat and dog pictures, what have you, employee information. That's kind of private data that's not really or shouldn't be available to the public. And lastly, the last component of the model are users. And users can be split into human users or system users. System users being functions that interact with other AI ML applications. The users can also be authenticated or unauthenticated. An unauthenticated user would be like a guest user, for example. And the third category of a user is authorized and unauthorized. When we're talking about unauthorized users, we're really talking about threat actors because they don't have the authorization to perform actions in the environment. Okay, so those are the components that actually make up the model. And so the next thing we do is take a look at the elements. And when we're taking a look at the elements, it's really how the actual components interact or how the components are interacted upon. Okay? And there are 7 elements: access, computing changes, AI changes, data store changes, invocation, private data, and proxy. I know that's a lot of words. I'm not going to test you on them, I promise. And we are going to go into a little bit more detail because there's more meaning to just the words than basically reading off a PowerPoint slide. But let's take a look at the elements in more detail. So the access element. With the access element, you want to ask yourself, or as a customer, do you still have access to your computing environment? And that's an important question to ask at the beginning of a security event. We often see customers that are experiencing security events. The threat actor has actually locked them out of an account, and so they do have to spend a lot of time regaining that access, regaining control of their environment. So that access element is an important factor to consider when you're using the incident response on AI model. The other thing you want to look at when it comes to access is whether there's continued evidence of unauthorized activity in your account. So you as a customer may have control, administrative control of your environment, but the threat actor may also still have control. So you want to take a look at that. And we'll go into a little bit more detail when it comes to the example incident. But that's the access element. The next element is with computing infrastructure and computing changes, whether there were actually any changes made to the computing infrastructure. Now, this is part of the model for incident response on AI, but this specific element applies to incident response in general. You want to see what resources were created, accessed, deleted, changed, or modified, and so we actually incorporate that with the model for incident response on AI as well. The next element is with the AI models, and again, this is part of the AI ML application. So you're looking at whether the models, your FMs, custom models, LLMs, if they were accessed or changed, and especially if any guardrails are changed as well. We have guardrails for security. If they're changed, you want to determine or find out if they were changed, and if so, how. The fourth element is data store changes. So we have, as part of our AI ML application, your models. We also have what's tuning or augmenting your models. And you wanted to find out whether the data stores or knowledge bases agents were trained or were accessed or changed as well. Now, as part of the AI ML application, there's invocation. And this, I think, requires a special mention, because when you're talking about AI ML applications and workloads, they primarily work on prompts and responses, right? So that's why the invocation element of the AI ML model is so important, because this will actually determine what data, what strings or files were sent to as input to the model, and it will also log any prompts and responses. So if the threat actor is attempting to perform prompt injection, you'll actually capture that with model invocation logging. Okay, then there's the private data element. So previously before I said that you may not, or a customer, an organization may not want to have their private data accessible. But if you take a look a little bit closer, there's like a dashed line. And the reason that's there is because in some cases, you may want, or a customer, a business, organization may want to have certain types of private data accessible. An example of that is if, for example, you're a healthcare customer and you have access to a chatbot, the chatbot has access to your own personal health information, then with restrictions, an AI ML application will have access to the private data. But generally, AI ML applications shouldn't have access to sensitive information like social security numbers and employee information. And the last element of the AI ML model is proxy, also known as agency. What functions can the AI ML application perform on behalf of a user? Do they have the authority to make changes? And as part of your investigation, were any unauthorized changes actually made? Okay. So with those components and the elements, I know that's a lot that I've thrown at you. I'm going to try and hopefully tie it together with an example incident and take a little bit more of a deeper look as to how we investigate those incidents. Okay, so here we have a user on the left, and the user on the left is actually an unauthorized user, and we know that because it's got the label threat actor there, right? And they've actually been able to access an organization. So the scenario is a threat actor obtains access to an organization via credentials they scraped from GitHub. How do we investigate this security event? So the first thing you do as an incident responder is you need to calm down and shake it off, which are also the 2 songs by Taylor Swift. And after you've done that, you can actually investigate the security event. And the first thing you want to do, again, access is the first element. So we're going to take a look at whether the organization has access to their environment or not, and identify whether unauthorized access to the account continues to persist. And we look at, primarily when we're conducting investigations, we're looking at the data plane and control plane. With control plane actions, the majority of those are going to be logged in CloudTrail. So with access, elements that have been performed in CloudTrail, we're looking at events where the source is iam.amazonaws.com. Now that's important because when you're looking at things like attach user policy, which is the 3rd bullet point, that's a form of privilege escalation that we've seen quite often. A threat actor will get into an account and they'll try to attach a user policy to a user that they have access to in order to get more permissions. And if that actually occurs or is even attempted, that's logged in CloudTrail, where the source of the event is IAM, Amazon, AWS.com. Another example of that is create access key, update access key. And that's a form of persistence that we've also seen. Again, if that actually occurs or is even attempted, that's going to be logged under CloudTrail, where the event source is IAM, Amazon, AWS.com. You'll also want to look at any unauthorized console login events. And thirdly, you want to look at events where the source is sts.amazonaws.com. Has anyone heard of STS? Yeah. From a security context, and especially unauthorized security event, you will see API calls such as get federation token and get session token. And those are two types of API calls that threat actors can often use when they're attempting to perform persistence. So if you take a look at that, that kind of encapsulates the access element of the incident response on AI. Now, the next element is computing changes. Again, we're looking for evidence of changes in the control plane and data plane. And you may need host-based logs. So if you have an EC2 instance, you may need to actually get the logs from the EC2 instance in order to complete your investigation. But let's see what that looks like in CloudTrail. So with the example incident, we see in CloudTrail a series of run instances. And if we take a look at the run instance events, there's 22 of them, right? A whole lot of them. Now, what do we make by 22? Well, maybe the threat actor is a big Taylor Swift fan and they wanted to do, because 22 is also a song by Taylor Swift. Anyway, I'm going to be done soon with the Taylor Swift references. Right.
Oh no, Taylor Swift is always referenced.
Okay,
Yeah.
fine. If you give me permission, then that's fine. But run instances is an event that's logged in CloudTrail, so is delete DB instance. There's also a series of CloudFormation events like create stack, execute change set, create change set, which uses CloudFormation to create resources. And then also, additionally, we've seen authorized security group ingress, which is actually a control plane event. But what that does is allow an entity or a user to access the data plane of a resource. So if you ever see that as an incident responder in your environment, you may want to take a look at the actual resource that's applied to, because that could be a sign of transitioning from the control plane by the threat actor to the data plane. Okay. So with the AI changes element, here we're actually taking a look at and identifying which models were used and if access was granted to additional models. We're going to determine if there was evidence of custom model creation or manipulation, and also take a look at whether guardrails were changed or accessed at all as well. And so specifically the example CloudTrail events that could constitute AI changes would be create custom model and delete custom model, and then list guardrails and delete guardrails. And you would see those two kind of in succession if a threat actor is attempting to manipulate your guardrails. There are also calls related to model invocation logging. So we talked a little bit about how important model invocation logging is, but a threat actor can actually remove the logging configuration, and what you'll see is API calls such as delete model invocation logging configuration. I think that's right, right? I mean, it's so long, but anyway, it's in the API reference for Bedrock, if you need to know more detail. And it's going to cover model invocation logging in a little bit in some future slides. But I'll continue on. So we also want to take a look at data store changes. We talked about AI ML models. Now we're taking a look at what's tuning or augmenting those models. We want to confirm that no knowledge bases or agents were tampered with. Some API calls, example API calls in Bedrock, would be create data source, get knowledge base, delete knowledge base, create agent action group, and delete agent. Okay. And then invocation. So we talked before about how important invocation logging is. Now, it's something also that I wanted to bring up because, for some businesses, some organizations, invocation logging isn't important, but it's kind of like data events. If it is important for you, maybe for regulatory concerns, it may be log heavy, but it's something that you definitely want to enable. And if model invocation logging is enabled, you can review the prompts and responses as part of your investigation for the security event. Okay, we also want to take a look at private data. So, we want to confirm that the customer's private data was not accessed or modified. And typically you would need data events to verify this, okay? Data events aren't always or aren't actually configured by default. So you want to make sure they're configured. And if you do see activity against private data, you would see actions such as get object, delete object, and delete bucket from S3. You'd also see RDS actions such as delete DB cluster, delete DB instance, and we've seen often a little bit actually modify DB snapshot attribute. So that API call actually allows a threat actor to modify a snapshot so that it's available to the whole world or to their specific account. Okay. And the last element of the 7 that we're going to cover today is basically proxy. So you want to take a look and see whether your AI ML application called resources on its behalf or on behalf of the user. And the way you do that is to look at the action where the event source is Amazon Bedrock or SageMaker. So before we looked at CloudTrail events where the mutating event had an event source of IAM Amazon AWS.com, you're now going to take a look for mutative events where the source is Bedrock Amazon AWS.com. And an example of an event you would see would be something like Lambda create function, SNS publish, or SES email. Again, these are all example events because of the example incident. There may be others, but this is a way that you can use the methodology to conduct incident response on AI ML workloads.
So I know I don't have an Australian accent, so you're back to the American accent. I know it's disappointing, but but what I want to do is we have the generative AI security foundations, introduce an element, walk through a example incident. How do we make this actionable for you as customers? So let's go back to what I think is the most helpful way to help customers is going back to industry framework. So here we have the incident response lifecycle from NIST. So what I have here is this is actions you would take in addition to the normal actions. So this is not discussing creating an incident response plan, right? This is really going into the items that are in addition to those foundational items. So starting with training. Awesome that you guys are here. I think this is a great first step because we have so many generative AI talks this week. I think it's a great way to learn about this, but I think it's super important because you can't respond to an incident in an AI and ML workload unless you have the understanding. So I think it's important to highlight training. It's hard because as a SOC analyst or incident responder, it feels like you have to know everything, right? Every technology that your organization uses. And then next is developing new playbooks. So where I would recommend starting here is within the OWASP Top 10. So we have a bunch of talks this week on that. Look at those. What if there is a prompt injection or training data poisoning? That could be a great place to start for playbooks and developing those playbooks. And then lastly, I know everyone came here and wanted to learn about a new log source they have to log, so I wanted to highlight that there's a new log source. And so here's the new log source. So say you are an organization that uses Amazon Bedrock. We are using Bedrock as the example. There are other services, obviously with generative AI. But what model invocation logging, which Steve had highlighted a few times, some scenarios of where you would use that, invocation logs, model input data. So if somebody types, how do I get Taylor Swift tickets? That would be in those logs. And then you would also receive the output as well within those logs. So I'll dive in a bit, but one other thing I want to highlight here is these are not on by default. it's something that you would have to enable. And then you have two options, well, three really, S3, CloudWatch, or both. So usually I would recommend for this type of log source to go to S3, and that's for cost reasons, because if you are using Bedrock and using it extensively, these may be a lot of logs to look at. So I would recommend S3 if I were you guys. So what are the differences between these? So CloudTrail logs, I'm curious, how many of you guys regularly query CloudTrail logs? Yeah, good amount of you. What about, oh, sorry. What about Bedrock logs, anyone? Not yet? Okay. Anyways, the difference here is CloudTrail logs would provide you more control plane information, whereas the model invocation logs would provide you more the data plane information. So the difference here being administrative functionality within the control plane, and then the model invocation logs would provide you more granular, the actual data that goes into the service. So if we dive deeper, seems like many of you actually use CloudTrail in your day-to-day. You can see here, hopefully, a familiar JSON object, and it goes into, you could see the region where the query was, the IAM role that was invoking this model, the IP address, things along those lines. And then here's what's different really about model invocation logs. And one thing that was important for like Steve and I is to like show you guys, what this actually looks like if you're investigating a security incident. So as you can see here, the prompt here is writing a haiku. Not super sensitive, but again, that's what you want to know as an incident responder, right? Is you want to understand what they were asking as well as what the output was. There's a few other items like the identity, timestamp, other just relevant things that you'll need to know as an investigator. So with this, as I stated earlier, detection and analysis, these are still initial identification of the incident and understanding the scope. This still involves understanding if it's an incident altogether. For AI and ML workloads, you should be familiar with some of these tools that I have mentioned here. The only one I would say is completely new would be the Bedrock invocation logs here. So just went over that, so I'm not going to rehash it. So one thing I do want to highlight here is like detection within generative AI workloads. It doesn't change entirely, right? If you're not familiar with these services, GuardDuty can still help, right? GuardDuty was not just created to detect threats in just a web application or just a data lake, right? It was created to detect threats. So we do have GuardDuty for XYZ service, but it's still relevant in terms of like credential compromise. Those threats are still the same and still do exist in generative AI workloads. So I think it's super important to highlight. Again, you can always create custom rules on top of that, but the foundations are still kind of the same in terms of using your threat detection tools. And then lastly, with config and security hub, having a secure configuration, like encrypt all the things, all of those like secure configuration items are still really important, whether it's using Bedrock or using S3. Next, containment, eradication, and recovery. So containment, isolating and minimizing the scope of an incident. This could mean, taking a system offline, or just simply like revoking access. Not a ton of change with an AI and ML workload, more how so you do it. Revoking the access would be just understanding the workload that you have and revoking it in that way. Eradication. So you see a bunch of different bullets here, I would say. So removing the threat and removing maybe poison training data, removing any credentials, and deleting any unauthorized resources. And then lastly, recovery. So this is putting your system or your workload back into production. So this could be restoring your model version, or I will say this entire containment, eradication, and recovery phase is this list is not exhaustive. There's a lot to it. So it's hard to even make a bullet list here because there's so much that could be occurring and what could be happening within your environment. It's not as straightforward as like detection and analysis where we could provide a list of like, look for this, look for this. It's a bit more, I would say, abstract, but we did want to at least touch on it as the foundations of, minimizing the scope of it, removing threats, and then bringing your system back into production. And then last but not least, I know it's not the most exciting topic, but as with any security incident, you should always learn from it. So this is not anything that's really changed, but you should discuss your lessons learned with your stakeholders and really improve your defenses. You could implement new detections, new preventions, still relevant. So what can you take home and hopefully bring within your organization? So I hope you take away, I know we've kind of harped on it, the fundamentals still apply. You have to prepare for an incident, develop your playbooks. You may have some new playbooks that you need to create. You should do new training, and it's awesome that you guys are here because hopefully it's helpful to understand these new technologies. Like I said earlier, maybe re-harping it, invest time in learning about your AI and ML workloads. This also involves understanding your internal use cases. So I know I've said, let's learn about all these AI and ML services, but you should also learn how is your company using it. Ask those questions of what's acceptable at my organization. That's super important to understand what's acceptable. How are we currently using it? Because it's probably very different between organizations, and understanding that will really help you with security operations. And then lastly, or not lastly, third, understanding how sensitive data is used within your AI and ML workloads. So you could be, using AI to recommend music, or you could be using AI to identify a tumor in an X-ray. The data that goes into that is really, really different, and the impact of a security incident is very different. So I think it's important to highlight, I know it's maybe not a technical control or something that you guys take away, but it's also something to think about is what are you using this for? Because there's a very large variety, whether it's, like I said, identifying a tumor, or we've joked around a bunch about Taylor Swift, recommending a Taylor Swift song. It's something to think about is where is your sensitive data? Because that's really what matters at the end of the day and how you're going to show impact to your business. And if you haven't heard about logging enough, we have a new log source. And then lastly, in the example incident that we showed, IAM is always going to be super critical for incident response, for security in AWS. So just ensuring you have least privilege is always going to matter. So I know we're an incident response talk, but IAM is still super relevant. And so it's still at the end of the day, kind of monitoring the credentials that are used, the IAM identities that are used within your environment is still going to be super critical to being successful here. Obviously, it's super cool to learn about the awesome new AI and ML stuff, but we did want to highlight the fundamentals are still here, right? Whether it's IAM, incident response itself, fundamentals really still apply. Lastly, here's some cool resources. Steve and I wrote the first one with a few other folks, so I would recommend reading the Incident Response Guide. It's pretty lengthy. If you like to read our writing for maybe a few hours, you can do that.
Yep. And with this session, we really wanted to, provide you with some insight as to how we respond and perform incident response on security events that involve AI ML workloads. And now hopefully you have that information. And then if we ask you or you ask yourself, are you ready for it? Then you'll answer, well, hey, that's also a Taylor Swift song, but yes, maybe I'm also ready for it. So thanks again for joining our session. Hope you enjoy the rest of your Inforce.